All right. Uh, Welcome to the Kubernetes Backup webinar where we have MinIO and Kasten. This is your host, Gaurav Rishi, and thank you very much for joining us. We have an exciting 45 minutes to an hour ahead of us. And, it's my pleasure to sort of introduce both the speakers and a little bit about the subject. So as you can see, we actually have both Vaibhav, who is the co-founder and CTO of Kasten, joining with AB, who's the co-founder and CEO of MinIO here today. And there's a very exciting subject in front of us. As you all know, Kubernetes and cloud-native backups are something that are becoming a here and now problem as a lot of applications are moving into production. So we're going to talk about what those challenges are, and I'll let Vaibhav talk about that. I'll then request AB to talk about what is this joint solution that we're talking about to get you a cost-effective and resilient solution to do your backups. And then we'll actually go ahead and do a real show and tell so you can actually see what it looks like. And not only are we going to talk about backup and disaster recovery, Kubernetes also brings with it the promise of portability across various enterprise environments. So we'll even touch on that. And then we want to keep this as interactive as possible. So we have kept time for Q&A. So please feel free to go ahead and ask your questions on the Q&A panel, and we will try and answer it as we get to it, either live or we'll definitely get to it. So with not much else to say at this point, but to really dive into it, let me ask Vaibhav to take this to the next step.
All right, thank you, Gaurav. Hi, everyone. Really excited to be talking about this topic today. AB, really excited to be presenting with you. So I'm looking forward to a good talk. So as Gaurav said, I'd like to start off the talk by really introducing the topic or really talking about what the challenges are. Before we talk about the solution, I think it's important to understand when we are looking at backup for our Kubernetes-native applications, why existing solutions that were built for example, VM environments don't really work over here. And when we're looking at these challenges, I think there are a couple of things to look at. One is not just how the infrastructure is changing, but also how our applications are changing, what changes are happening to the architectures, and also what's changing culturally, what tools are we using, what processes are we following in these environments. All of these are kind of drive or kind of illustrate these challenges that us and our customers hit. So the first one to look at is really at the infrastructure level. If you really look at what Kubernetes is, it's going to be an abstraction over multiple virtual machines or nodes where applications are going to get deployed. But really there is a strong impedance mismatch now between these containerized applications and virtual machines. You no longer have a one-to-one mapping between a virtual machine and an application. In fact, given a microservice-based application, you will often have it running across the cluster on different kind of nodes. You also have the inverse issue where on a single node or a VM, you can have multiple applications running. So backing up a VM in these environments really backing up or restoring a VM doesn't really buy you a lot and doesn't give you the granularity you need. The other thing to focus on, or the other thing that creates challenges, is really the cultural change that has happened and also what's happening in how these applications are built. We are moving to more self-service kind of infrastructure where the focus is really on the application and the components that it needs. We have infrastructure as code, where every application is different from each other. And really the focus is no longer on managing individual pieces of infrastructure, making sure they're protected, but really on how to back up and restore an entire application and its stack. Very related is also what's happening with the scale of these applications. As we are moving to more self-service environments, as we're moving to microservice architectures, what we're seeing is applications are, their footprint is growing. You no longer have single component applications. You have applications with multiple data services, SQL, NoSQL, message queues, caches, external data services. And really, there's an explosion in the number of components that belong to an application. And then lastly, I think this is really important, is that whatever solution we build for these environments needs to work with all the other tooling and the infrastructure changes that we're making. We don't want to be managing any solution differently from how we're managing our deployment pipeline, or how we're managing our monitoring or logging or any other storage solution in this environment. So it's really important to have a Kubernetes-native integration, API support. As we see these applications come in with these different data services, having that first-class integration with things like databases and NoSQL systems, integrating into cloud-native monitoring, alerting, this becomes really important. And these are kind of the challenges that make it hard to kind of take an existing solution that was built for more of a virtualized world or a bare metal environment and integrate it into Kubernetes. So what is really the right approach? And I think based on what we just talked about, the right approach here is really to focus on the applications as the operational unit. You might have noticed I mentioned that word over and over again, applications, and it really is a reflection of what we really care about in these environments. We no longer care about bringing back just a volume or just a database, because that doesn't mean anything. What you really want to make sure is that you're discovering and capturing all the components of an application that you need to bring it up in the environment that it is running in. The other thing that's really important, and if you start looking at how Kubernetes abstracts on top of multiple storage systems, multiple environments, whether it be public or private cloud or hybrid cloud, I think it's really important to continue to respect that abstraction, which means that you need seamless support for any kind of storage system or data service that the application is going to consume or actually bring in with it when it gets deployed. And then lastly, and this is where things often fall apart, it's really important to make sure that you have a coordinated, or you have a single playbook for backup and recovery in these environments. Multiple playbooks to, for example, back up a volume or a MySQL database or a cloud service that you have to go and orchestrate manually to bring back, or an application, doesn't really work in these environments where everything is moving so fast. So that's really what is going to motivate the solution that we're going to talk about. And I think there are a couple of components that we would like to kind of highlight. The first one is just to talk about MinIO and why that fits in really well over here, is to have a solution that can give you the resiliency and performance that you need in these environments. Again, addressing the challenges we talked about, where you have an abstraction over any kind of environment you are running in. MinIO is a really great fit. It's software defined, it's high performance, it's built for these kind of applications, which is what we're talking about. In addition to that, it has the cloud native integrations that we're talking about. You'll see this as we get to the demo. It is truly a cloud native solution with native Kubernetes integration. I'm talking about this. I know, AB, you know a lot more about what you're seeing, but just from an external point of view, the community traction you have is just amazing to see. It's just fascinating. Over 377 Docker pulls, amazing community that is behind this. Hi, folks. I might have dropped off.
Yeah, we can hear you now.
All right, great. Where did I drop off?
I just temporarily froze, but you're fine now.
All right. Thanks for that. So the next part really of the solution is Kubernetes, Kasten's K10 product, which is really what enables backup and mobility in this environment. And we'll talk about how this integrates with MinIO in a couple of slides. Our K10 platform is focused on enterprises, on really that large scale. It's built for the operations team in mind. It is built so that they can get automatic discovery of all their applications. Everything is policy driven and automated, simple, easy to use, a user experience. and then really gives them the end-to-end security, whether it be for data in flight, whether it be how things are persisted, encrypted on disk, support for things like customer managed encryption keys, enterprise grade authentication, RBAC, all of the tools that you really need to have an enterprise grade backup solution in this environment. If we look at just at a high level what the architecture looks like of deploying these solutions, really this is where the flexibility of choice comes in. Both K10 and MinIO will deploy on any virtual or physical infrastructure that you have running in your environment, on top of which you have obviously the container orchestration platform, which is Kubernetes running. And there can be different kinds of applications running in these environments, whether it be cloud native or a legacy app that you kind of lift and shift into these environments. The K10 platform and MinIO both deploy on top of this, on top of Kubernetes, and then integrate natively both into Kubernetes as well as the underlying infrastructure to discover any components, any stateful components of the application, as well as all the Kubernetes resources that are needed for this application. In addition to that, K10 also integrates into the applications itself, which allows you to do application level backups. For example, if you want to extract data at a MySQL level or from a Mongo tool or something like that. AB, I'm going to hand it over to you just to talk about the overall solution.
Yeah, I'm going to also double click on the storage layer particularly. So the overall solution, like when you combine a Kasten and MinIO to build a high performance distributed snapshot recovery, backup, what's the particular challenge here we are talking about? Right? Historically, applications were scale up, and it was easier to snapshot just at the block layer, and you were done with that, right? But as you move towards a more cloud native world, every single application out there is a collection of containers, and it's really hard to now back up and restore. The challenge particularly here is storage layer has no context of what the applications are and what the collection of those containers, how they are related, how they need to be coordinated. If you took snapshots independently, if they coordinating them, the storage layer has no idea. And here is where that Kasten's Kubernetes-Native integration knows exactly all this in the namespace makes up a snapshot. And to be able to coordinate that requires a tighter integration into the Kubernetes layer. And like there are many types of artifacts, from secrets to database snapshots. There can be a persistent local volume and container images, all of them getting coordinated as one collection of snapshot. That's actually something, it's a relatively newer problem as the applications went scale out. And K10 platform coordinates all that and gets a collection of these snapshots into one object storage repository. So from MinIO's point of view, the job is to keep these snapshots outside of the application. So if there is any catastrophe, you can recover. So you don't keep the snapshots along the side of application, and when something goes wrong, all your bets are off, right? By keeping these snapshots outside of the application into an object storage, and the object storage itself can keep the data safe by erasure coding them. I'll soon talk about that, how exactly your data is protected, how the snapshots comes into object storage, and object storage can not only protect the data within the data center, it can also keep a copy of all your data across data centers, even in a multi-site active-active fashion. So you're pretty sure that once your data is snapshotted, that is hardened and it's kept safe no matter what the failure is, right? It can withstand multiple drive failures, node failures, or even the data center failure. And in addition, the objects are erasure coded, bitrot protected. So as the drives age and see silent data corruption, your data is protected from those all. And you also have object locking and encryption. So even the administrator cannot go back and tamper them, having physical access to the drives, still the administrator won't be able to intentionally or unintentionally manipulate the data, which gives you the peace of mind, right? And now we will go into the details of how exactly MinIO protects the data. Next slide.
I'll go there. And AB, I think that is a really important point that you made, which was, backup is really all about making sure that your data is in a different fault domain, and you really want to extract it and put it in somewhere which gives you that performance and gives you that peace of mind with all the features that you mentioned. So I think that's a really important point that you highlighted there.
So we are digging deeper into how exactly MinIO works, and once you understand the high-level architecture here, you will understand how MinIO works. The MinIO strength really comes from its simple, elegant architecture. Someone without storage expertise, without knowing what erasure code or bitrot is, they are able to set up and operate, right? And that's and the reason for all that simplicity really stems from the architecture itself. Right, the entire MinIO server is just like a 46 megabytes now, right? It's a single static binary written in Go, and it's in a Kubernetes environment, it's pretty much a single command to set it up, right? And underneath the hood, this is how it looks. You start with a collection of servers. In this example, this example actually shows internally how the commands look, but in a Kubernetes environment, all these are abstracted. Right here, it's a 16 server, 48 drives in each one of those servers. It's called a zone. A zone is simply a collection of servers. And MinIO starts this way, combining all those drives into a distributed erasure coded object storage. And now we have been taking snapshots continuously, or application data and backup. At some point, you run out of space, or the performance it reaches the peak. MinIO should be able to peak the hardware performance. The overhead is so little, we are able to pretty much linearly scale and saturate either the drives or the network, whichever is slowest. And once you hit that limit, right, you want to now scale, you always scale on demand as and when you need. Go next, Vaibhav. Yeah. You can keep adding new zones. A zone is a collection of servers. It could be collection of racks, right? And as you scale, they are going to be heterogeneous, because by the time you buy new machines, the newer hardware is cheaper and faster. You can't avoid it being heterogeneous. So you keep scaling this way, right? You keep going. And you will see that this is pretty much how you keep adding zones. And when you want multiple data centers, just like AWS regions, you expand your data center geographically. And I'll explain how the whole global federation works. The nice part is that object storage takes into account of federation by using DNS names and region as a label to identify where the objects go. Right, and next slide. So the buckets, like when you create buckets are like volumes, right? And buckets determine which data center you're talking about. A bucket, when you create a bucket, go next. You have to let the system know it's part of the S3 API. When you create a bucket, you want to say, I want to place this bucket in US East data center. And then the bucket gets automatically routed to the US East. Now, US East may have just 4 servers, or maybe 4 racks, or 40 racks, right? It doesn't really matter. Your bucket spans your entire data center. And there is no space reservation. It's thin provision, so it can keep growing. And as you create new buckets, the buckets choose different regions. Then if you want to fetch an object in a bucket or place an object in a bucket, you simply choose the bucket name. Every object request tells the bucket name, and bucket name determines which data center you need to go to. And within the data center, the MinIO server knows with a deterministic hashing technique. It knows exactly which erasure set your object is. There is no metadata database. It goes straight to the drive set and pulls the object out of the drives, and machines can die, nodes can die. It can withstand multiple nodes, a rack level failure, and your data is always online. Next. Yeah, that's about it. And now Vaibhav actually will go into a demo session. That's the interesting part, right? In the end of the day, seeing it working. Go ahead, Vaibhav.
All right, thanks, AB. Yeah, we wanted to make it interactive because I think it's always good to see these things in action. So let me talk a little bit about what we're going to demo today. What I'm going to do is I've got a couple of Kubernetes clusters set up. One where we have some applications running. We also have MinIO deployed. So we're going to demonstrate how app capture really works in this environment. And then what we're also going to do is after we capture the application, after we back up the application, we're going to use that to demonstrate not just restore of the application, but how can you restore in a completely different cluster from that backup. And I think that is where you'll really see all of the things that we talked about really come together. So let me switch to my demo setup over here. First, just a kind of terminal view. I have two Kubernetes clusters set up. You can see that I have a VK demo source cluster, which is running in Google and GKE, and it's a 3-node cluster. The other cluster is a target cluster, and you can see this one is also very similar. It's a 3-node cluster running in GKE. Switching back here just to the first cluster, just to show you what's in here before we kind of jump into our interactive demo. You can see that I've got a number of applications deployed. I actually have Kasten and MinIO deployed in this environment. But more interestingly, I've got a couple of Mongo deployments and a MySQL application deployed. And this is what we'll use for our demo going forward. So to install both K10 and MinIO in this environment is, as we mentioned, is really very straightforward. To install Kasten, we support a number of different Kubernetes distributions, and installing us, for example, in Google Cloud is just a single line very similar to that, given that we are both built for Kubernetes natively, is MinIO as well. And this is the download page for here, where you can see it supports a number of different environments. For me to deploy in Kubernetes, again, is just a single install command. And that's kind of what I've run here to set up the demo environment. After I go ahead and run that, MinIO is set up. So you can see it's running in my demo environment here in GKE. I actually have a single bucket created called demo, and we'll explore what's happening inside that bucket in a little bit. This is my source cluster running in GKE. And what you'll notice is as soon as you deploy Kasten inside the source cluster, we also deploy our full-featured enterprise platform and the dashboard over here. So this is the dashboard view that we're going to use for the demo. This is deployed by default. And just to give you a quick tour of what we're seeing here, under the applications view over here, you'll see that Kasten has, or K10 has gone and automatically discovered all the applications that are running in this environment. The compliance view over here really tells you which applications you have backup policies associated with, which applications are not being protected. So this gives you a quick snapshot of where you might need coverage. Policies is where you can go and create new policies to manage your environment, and we'll go click on this a little bit later. Over here is where you can get a quick summary of where all your data is stored, how much backup data you have, how much is stored in object storage, how much dedupe you're getting, and so we'll talk about that also in a little bit. But if I go navigate over here to settings, what you'll see is that we support a number of backup targets. And in this case, I've created a backup target, which is using that MinIO deployment that I just created. So that's the endpoint, and I've gone ahead and created a demo bucket over here. Now, navigating back over here, just below the fold is where we're going to see all our activity, everything that's going on in the system, and we'll come back to this. So let's start off by looking at what applications I have. So it's not just what are the applications in the cluster. K10 is also monitoring and discovering what are all the different components of that application. So you can see that if I go look at one of these MongoDB deployments and I go look at details, we've automatically discovered not just the application, its labels, but also what are all the different data components that we need to capture, what are the Kubernetes workloads that need to be backed up, any networking components, configuration, anything that you need to recreate this application from a backup. We are automatically discovering, and we do this on the fly, which really takes care of redeployments or upgrades of this application. So we're always constantly monitoring what's happening in this environment. You'll notice that I have a couple of applications that are that say compliant, but I've got one over here that is not protected by any policy. So let's go ahead and actually create a policy for this application and see what that looks like. So a policy is how all the work starts in the K10 platform. This is really what creates that automation that you need. So in this case, I am creating a policy that is going to start off by snapshotting the application. You have the ability to configure how often these snapshots should run. You can get more granular if you need to. You can actually schedule exactly what time you want these snapshots to run at, if needed. You can control how long these snapshots that you're taking should be retained for. You can, everything from hourly, weekly, yearly. So it allows you to really set policies according to any SLA that you want to provide. Finally, the next step really is to enable backups. So snapshot really captures the data and creates a local copy for that. But when you hit enable backups, this is really what takes those snapshots that are local to the cluster and moves it to the backup target that we configured. And in this case, we've configured that MinIO target as the backup location. You can also control how many snapshots you want to keep local. Do you want to move everything to the external storage? So you could say, I want a snapshot every hour, but I only want to move every daily snapshot to external storage. So you have a lot of flexibility over here. And you can also control what is in the backup target, independent of the retention that you have for the local snapshots. So a number of different options that you have over here. I'm just going to go select the default. But it gets interesting when you start to select which applications this policy should apply to. So over here, you can get very specific. So you can say, okay, I only want this to apply to the MySQL application or maybe the Mongo application. But you can also create broad policies that apply at the cluster level. So you can use Kubernetes labels to say, for example, everything that was deployed by Helm, I want this policy to apply to. So it gives you a lot of flexibility in creating these forward-looking policies as well, so that no matter what application gets deployed, you'll be covered. In this case, I'm just going to go pick that MySQL application and then go ahead and create this policy. Just before I hit create, I want to highlight this button and really talk about what you're seeing on the dashboard. So everything you're seeing on the dashboard, every feature here is actually backed by a Kubernetes-Native API, which means that it's easy to automate. And also because it is a Kubernetes API, it integrates with any of your tools, any other tooling that you might have. So it's very easy to kind of make part of that workflow that you have. So let me go ahead and hit create policy over here. And what you'll start to see if we go back to the dashboard is, first off, I no longer have two unmanaged applications. I have one that's now moved to non-compliant, which really means I have a backup policy that's covering it. This is the MySQL application, but it hasn't run yet. So we're not yet in compliance with the SLA we wanted. So let me actually go ahead and run that policy manually, just for now. Otherwise, it's just going to run on its schedule. And if I go back over here, you'll see that that job got scheduled. So it's running. And our compliance immediately switched to saying that we have 3 applications that are now compliant. What you're going to see over here is that we're discovering, again, at runtime, all the components of the application, whether it be data or Kubernetes resources or external services that you might be using, and automatically capturing that data as part of that backup operation. And as soon as that local snapshot completes, which it did, you'll also see that another job will get scheduled that is going to move that data into that object store location. So that should happen on the schedule as soon as the system detects that. If you scroll down, what you'll see is that I have other jobs that have been running for a while. And this is that export that I was talking about that's going to move the data into object store. So I'll let that run. But if you scroll down, you'll see that I had a job that ran like an hour ago for Mongo, as well as for the 2 different versions of Mongo. But what you'll notice is that the artifacts are slightly different. And this really talks about the different kind of integrations that K10 has into not just the underlying storage layer, but into the application stack if needed. So one method to back up was really to leverage volume snapshots to capture the data. And that's what you're seeing over here. That's this job over here. But if I go look at the other run over here, you'll see that we did not do any volume snapshots, but actually what we did was actually use a MongoDB tool to capture a application consistent Mongo database backup. And so K10 has the flexibility of doing that. And both of these would have been moved to that MinIO target that we were talking about. So just to show that happening, if I go back to my browser and I go look at K10 over here, you'll see that K10 has locations it's created for each cluster. And inside those clusters or inside those locations, you actually have those exports that we ran, as well as the data components. Again, it's not going to make a lot of sense to just look at this because all of this data that is being moved over here is all encrypted and stored encrypted in this environment. But this is just to show all the data that has been moved into that location. If I go switch back over here and just show you the data view as well, you'll see that at this point, we have 72 gigs of kind of snapshot data that we've captured. And we've also moved things to object store, but you're seeing that we're moving a lot less to object store. And this is because K10 has an inbuilt deduplication layer where it's only moving bits that are unique across to the backup target, gives you efficiency both in data transfer, but also in terms of your storage usage. So what I'm going to do now is switch back over here and go show you the other cluster I have. So this is the demo target cluster. And you'll see that I don't have any applications running over here. I just have a default namespace. And that's about it. So what I'm going to do is I'm going to switch back to my source cluster, and I'm actually going to import the backup I took from here into that cluster and then restore over there. So if I go back to, for example, my MySQL backup that I just took, you can see that I took this backup at 929. This is really the local copy. This is the copy that got moved to the MinIO target. And I can actually go ahead and restore that over there. Oops, give me a second. And the way to do that is just to grab back. If I go back to my backup policy, this gives me a token I can use in my other cluster to set up what we call an import policy. So I'm going to navigate over to my other cluster, and what I can do over here is say create a new policy, and in this case I'm going to import from source. It's an import policy. And what I'm also going to say is this policy should restore automatically as soon as it imports from that MinIO target. You can configure this to run on some frequency. That means that anytime the backup gets refreshed, you can pull in the latest if you want to. So I'll run it on a daily frequency, and I will paste that token over here. What you'll see is that it's automatically detected where the backup needs to be pulled in from. It's pulling it in from that same location. And then I can go ahead and create that policy over here. Switching back to my dashboard over here, what you'll start to see is as soon as that policy kicks in, an import job will get scheduled over here, pull in the data from the object store, and then go ahead and restore that. Let's run it again and make sure that's happening. So that should start to show up as soon as the controller detects it. And we will run that. There you go. So a little bit of lag for the dashboard to update, but you see the import actually was very fast. It completed. So it's actually pulled in the data from that. If you remember in the object store, we had talked about that repo path. That's where the data got pulled in from. And what it's doing is it's automatically now restoring that MySQL instance that we backed up over here in this environment. And just to show what's going on here, if I navigate to my target cluster, what you'll see is, first off, a MySQL namespace that got created 38 seconds ago. And if I go and look at what's happening in that, if you go look at what's happening inside that namespace, we've automatically created a new volume. We've actually brought in the data that from the object store into that volume. And now you can see that that MySQL pod is starting over there, and shortly it should be running. And there you go. So that MySQL instance now got imported and is running there. And it's not just the MySQL, for MySQL to come up, it's not just the pod, but it's also the secrets, the config map, everything that you needed for the application to run in this environment. Last thing I wanted to highlight before we kind of wrap the demo up is that there's a lot of flexibility in terms of what you can do when you're restoring. So I showed a kind of very simplified restore, which copies and restores the entire application in the other cluster. You also have, using those restore points, the ability to clone within the same cluster if you needed to, and also pick and choose exactly which components of the application you want to bring back. So maybe secrets are auto-generated and you don't want to bring those back. So you have the flexibility to do that over here as well. Okay. So that's really the demo. I'm going to switch back to slides and talk about one more aspect that we kind of touched on briefly before I hand it back to AB. And that is really how to capture data in these environments. You know, we talked about, there are multiple ways to do this. One of the ways we talked about is if you've got, for example, a MySQL database or Postgres database, to leverage storage snapshots to capture the data and then feed that data through K10's dedupe engine into the backup target. But often, you know, if you want more consistency, there are other ways to capture the data as well. And we saw a brief example of that, which is to use a data service specific tool like MySQL dump or Wally for Postgres or Percona tools, anything that you want to use that can give you that consistency that you need at the application layer or at the data service layer. And then there's a third mechanism, which is also to have a coordinated approach where you can use data service specific tools, for example, to quiesce the application, but then still use storage level snapshots to capture the data. So K10 supports all these different modes of data capture, and we have kind of blueprints that extend the platform that we have available for Mongo, MySQL, Elastic, Postgres, any kind of data service that you might be using, things like managed data services like Amazon RDS as well. And the platform is very extensible using what we call the canister blueprints. So you can easily kind of plug in any extensibility you want in there. AB, I know I spoke a lot. Hopefully this gave a good picture to everybody. I'm going to hand it back to you now.
That was a great demo. I think the demo is the meat, right? So to summarize, right? So why like bringing both object storage and a snapshot resource system together, like K10, what is the real benefit here, right? The key here is it's actually simple, right? If you see the demo, how easy it was to achieve sophisticated concepts from dedupe to scanning the namespace. Well, you can see it hardly requires Kubernetes expertise. Someone from your IT staff with very little training can actually manage the whole system. The UI is so self-explanatory that you don't need to read a lot of documentation to be certified, trained technician to be able to operate this infrastructure. That to me is the fundamental requirement to building very large infrastructure. Most people don't realize that the most important requirement is for scale is it has to be easy and it has to be simple. And Otherwise, as you scale, the complexity is the one that's going to bite everything, right? It becomes expensive. No matter how fast a system is, if it is complicated, it is not going to scale. You will lose most of your money on people. As you scale, you are going to add more people. And if you are going to add more people as you scale, you are not scaling at all. And how do you solve this? Everything has to be simple at its heart, and it has to be software defined. Once it is software defined, you can automate everything. Let Kubernetes framework enable this full scale automation. This is where everything comes together very nicely, right? If you haven't automated, then you are not letting software do the job. And for automation, you need to treat that everything is a software problem, starting from storage all the way to backup and restore. All of this, treating this as a software problem, now you can roll it out on public cloud, private cloud, pretty much any Kubernetes environment. And once it is automated, then it's one person's job, right? Pretty much you can see that someone in their part-time can entirely manage both storage, backup, restore, the snapshotting automation. And when it is all done underneath the software layer, what you also get is like end-to-end encryption to object locking. Object locking also is called object immutability. You want to make sure that when the snapshots are returned to object storage, there is no tampering allowed, and any such tampering is blocked. Basically, the permissions are created in a way that when objects are returned into the system, you for say next 6 months, I don't want anybody to tamper, or maybe next 3 years, I don't want this object to be even deleted. We can set such policies at the object storage level as well. So end to end, you got the data protection, and you can see that one of the cool aspects of what Kasten did is once you create these snapshots, you can actually recover them and recover them in any other environment, and to be able to test it, that now you can think about even routinely pulling out of the snapshots. One of the aspects actually when Vaibhav was showing the demo, there is a cron job like effect for even the restoration. Now you can actually routinely pull them, verify them, maybe do some ransomware scans, right? Every time you want to make sure that every backup is actually done to certain requirements. How do you know that? You want to don't restore when things go wrong, right? Like restore and check them routinely, so you know that when something goes wrong, the predictability is super critical. That the last thing you want is when something goes wrong, you don't know how. Like that's not the time for you to go recover things from snapshot and see that things are gone well, right? Like the skill set required when you are in a panic mode, if you are not going to find someone else, so maybe the engineer who set things up is not around at that point in time. You to be able to verify every single time you took snapshot and do it in an automated way end to end is so critical. So all of this basically is a result of everything software defined, everything is automated through native Kubernetes interface and presented in a simple way that anyone can pick it up. You can see someone from your even software development team, your application developer or IT, pretty much anyone can run this whole infrastructure.
Thanks, AB. That was a great summary.
Yeah, these are some great resources. I think Vaibhav can share the slides as well, right, to the public after.
Yeah, we'll share the slides, and that'll they're all clickable, so you'll have a lot of kind of interesting resources to go and read more about.
Yeah, and I think it's time for questions.
Sure. Hey, thanks, AB. Thanks, Vaibhav. This was actually definitely a good flyover tour. I think we managed to cover a lot of ground, and then at times dive in. So just as a quick reminder for folks, I already see some questions coming in, but there is a Q&A button you can press, and please post your questions, and we'll try and address them. But I'll get started in the interim, and I'll try and maybe direct them either AB or Vaibhav's way, but please feel free, both of you, to answer it. So I think Vaibhav, maybe the first one towards you, which was what modern databases can Kasten support? And can I'll just club another one, which is associated with it. Can you also back up distributed systems like Redis? So I know you had touched on this, but maybe if you can elaborate a little bit more.
Yeah, no, that's actually a great question. Yeah, so Kasten can integrate. One of the slides I talked about is the different kind of data capture mechanisms we can leverage, both from storage snapshots as well as using application tools and data service tools. And what that really allows us to do is integrate with not just kind of single node systems, but these distributed systems such as Cassandra, Mongo, Postgres, Redis that are out there. So we have native extensions that we have for things like MySQL, Mongo, Elastic, all the kind of popular cloud native data services out there, with the ability to either extend it for any other system. As long as there is a mechanism to capture the data available, that can be integrated into the backup workflow, again, in an automated way.
All right, no, that's great, thank you. The other one is, I know both of you pointed out that not only is it a single click or a single command install for both MinIO as well as Kasten K10, and it's software centric, obviously. But I think the question maybe AB your way is, what are the hardware that MinIO object storage support, and does it support Cisco UCS 3260?
Yeah, so from MinIO point of view, being software defined, again, software defined is poorly understood from a typical IT point of view, because you will see that pretty much the hardware vendors, hardware appliance vendors also call themselves software defined now. Anything today, whether it's your watch or TV, it contains software. If it contains software, it doesn't mean it is software defined. Software defined means you download from the website or from the Helm chart or pretty much anywhere from a repo, and then deploy it on a commodity off-the-shelf hardware, right? From MinIO's point of view, that is what it means. And we have seen extreme scenarios, right? We are getting deployed in 5G towers running ARM chips, even home NAS solutions. We never designed it for personal use, but because it is so easy, people deploy it anyway. From there to high-end IBM Power AI team runs MinIO natively on Power architecture. We run inside hard drives to even chips, but the common ones that we get deployed, the Cisco UCS series, that 3260, that's actually a great box. The ones that I would typically recommend for production environment today is a standard Linux operating system, Red Hat, Ubuntu, and a server with a bunch of drives. A dual Xeon, even a single socket Xeon with lots of cores is sufficient. We are mostly IO bound, the drive or the network. So a bunch of drives, no read controller, plain SAS expander, because you want the maximum dollars, like maximum capacity and performance for every dollar you invest, which means just take a commodity server with a bunch of drives, and you don't need anything special. We have seen that just a commodity server is able to saturate 100 gigabit Ethernet, and you don't need anything special. So even an AMD processor is actually pretty good. AMD or Intel standard CPU. Memory, even 64 GB is plenty. MinIO takes very little memory. Often your vendors will tell you 192 is the minimum you need to be balanced. So invest in good network, good amount of drives. More drives, the better. Hard drives are plenty fast for even high performance requirements. But if you are talking about ridiculous performance, then go for solid state, all flash. But MinIO is optimized for pretty much both hard drives and SSDs and commodity Ethernet standard Xeon CPUs. Cisco UCS series is actually the box that you mentioned, 3260, is a dense JBOD. It's ideal to get the maximum performance and capacity for the dollar. You'll find that you will get primary storage performance at a price point that no archival vendor can compete.
That's great. Thanks, AB. I think that answered not only that question, but I think another question about MinIO read-write performance and can you use object storage solutions for quick recovery? And I think you just pointed out that you have a freedom of choice of the hardware, and you can actually use that to indeed get to quick recovery. So I think maybe sort of moving on, I think the question next is maybe Vaibhav your way, which is Kasten meant to be used by application owners themselves without having cluster admin rights, example, in a multi-tenancy environment like OpenShift? So maybe you can expand on the RBAC, and I think that's what this is.
Yeah, no, that's a great question, and I regret maybe not talking about that a little bit more in the demo. But really, Kasten is built for multi-tenancy in mind. So one of the things that I did mention is everything that you saw on the dashboard, again, is backed by an API. But it's not just backed by an API. We have granular rollback controls for each kind of operation that you have over there. So what that gives you is the ability to say which namespaces can be backed up or restored by which owner, which entity, who can create policies, who can do restores, who can view or create object store credentials. Everything over there allows you to kind of operate in that multi-tenancy environment that the person asking the question was talking about. So going back to kind of application owners, so if you've got a cluster that has multiple application owners, this allows the application owners to only protect and restore their own applications and not have a view on everything else that's going on in the environment. So I'm glad the question came up because it's definitely something we spend a lot of time on, and it's very powerful.
Very good, thank you. Maybe I think this one might be your way, which is can we make use of Hive as querying engine with MinIO or any other querying engine which gives better performance?
Yeah, so this is for the big data type use case, and the answer is yes. So Hive uses S3A adapter. S3A makes object storage, S3 compatible object storage look as if it's HDFS API, right? So HCFS is the Unified File API. HDFS the HDFS API sits beneath HCFS, right? So the S3A adapter, MinIO is fully compatible with, and we have posted a good amount of how to tune, how to configure it right. And this is how even Amazon EMR works on basically the entire Hadoop stack to their Athena, which is built on Presto, Spark, all of them uses the same S3A adapter. And so what other alternatives exist? I actually like the more modern ones, like the Hadoop stack still carries a lot of legacy baggage because it is written for a data and compute co-located model. The more modern ones, starting from Spark, Presto is another emerging one. It has a lot of potential. It came out of Facebook, and I'm also seeing a bunch of Splunk-like alternatives, MinIO, and there are quite a bit of them. They say, let's take Presto. Presto and Spark are the most prominent ones. And they actually are designed for a disaggregated storage and compute model. So the the processing engine runs on the compute nodes, and they pull that data at high speed from MinIO. So while they use the S3A adapter, these modern ones also have gone native S3 API instead of making object storage look like a HDFS. There is no reason to make an object storage look like a file API. File is considered legacy in a modern world. Object storage has gone to even next level. It's called S3 Select. You can even push down a SQL query all the way down to object storage. And say if you have a giant CSV or a JSON or a Parquet compressed object, you can query them without downloading them. And MinIO has a SIMD accelerated SQL query engine that you can query a CSV object without schema at very high speed. Some of these, like Presto and Spark, actually has taken advantage of them. I can see Vaibhav is Vaibhav is like smiling at it because he very early on in his career he worked on WinFS, which was the true it was the right vision back then, right? It was probably ahead of its time, but it was about convergence of file system and database. Microsoft put this idea forward. Finally, we are seeing the light of it at much larger scale. But it was Vaibhav actually worked on that project.
This is fascinating. So, Vaibhav, I see, a part two to the career, or part four, I should say. But that's fantastic. All right. So I know there are a couple more questions and maybe a couple more minutes. So I'll try and keep the pace here. I think the question really in this context is also, Vaibhav, maybe your way. That I know we kind of kept the focus here in terms of resilient and backups, which can work at scale cost effectively, which was the subject of this. But I think you had also mentioned application portability. So the question is, can you elaborate on that, and what are the changes required for my applications if I want to move them from an existing upstream Kubernetes deployment?
Right. No, good question. So portability, actually, we haven't talked a lot about in this talk, but it is actually in these environments turns out to be very important. Simple use cases, whether it be upgrading clusters. So if I'm going from OpenShift 3.11 to 4.4, that's a major upgrade. And instead of doing that in place, what we found is for most customers, it's easier to deploy a new environment and kind of migrate into that, as well as supporting use cases where I might be running in multiple clouds, or I have a hybrid use case where I'm running on-prem as well as in the cloud. So it all starts, how K10 actually plays a really big part enabling that. It all starts by capturing that data and capturing it in a infrastructure kind of independent, a portable format, which is how we capture the data and move it into the object store target that we showed. From there, in our demo, we restored in GKE, but I could have actually restored in AWS environment, on-prem, in OpenShift. All of that would just work seamlessly in the platform. Then there are things that need to change, for example, in the application. Sometimes there are static ports or IP addresses that need to change. There might be APIs, for example, if you're moving from a upstream Kubernetes distribution to OpenShift, where APIs need to change, or between versions. And so K10 has a transformation engine that is kind of built in into the restore workflows, which basically allows you to do kind of define these transforms that should happen automatically, and K10 will do that as it's moving the applications into your environment. So again, it's all declarative, it's all API based, it's all just kind of that automation that AB was talking about. You define it once, and then the platform will take care of it.
That's great, thank you. So one quick rapid fire question for you, Vaibhav, and then I think I'll try and squeeze in one for AB also. So I think obviously you made the point that snapshots are not backups, and that's why you need to sort of have different fault domains. But maybe if you can, Vaibhav, talk very quickly about what are the different storage systems that K10 supports for snapshots?
All right, yeah, I'll do it quickly. We have native integrations with all the cloud platforms out there, as well as things like Ceph and Cinder that are native integrations into the platform. We also have native support for CSI. So CSI is the container storage interface that the Kubernetes community has built, which almost every storage vendor out there supports. So that allows us to support a variety of kind of storage systems out there, things like Pure Storage, which we work really well against, and things like EFS and vSphere, First Class Disk is also things that we have native support for in the platform.
That's great. And AB, maybe the last one for you, which is I think a good meaty question, which is, are MinIO operations like write strictly consistent, and what is the benefit of strictly consistent versus eventually consistent for the kind of use cases we talked about today?
Yeah, that's a great question. So MinIO is strictly consistent. Even Amazon S3 is not fully strictly consistent. The reason why everyone else went to eventual consistency was because it was easy. You need to get high performance, and eventual consistency gave them an opportunity to do things in a delayed fashion, right? But so it also came as a result of a metadata database, and your data you're updating in multiple places. Doing this atomically with that is strict consistency is actually hard. You take a hit on the latency. And it's not the case for MinIO because of its architectural simplicity. It really stemmed from solving one problem only and being focused on just object storage and S3 API, and also inverting the stack. Without going into the details, MinIO is strictly consistent, meaning every operation that you perform on MinIO is atomically completed. There is no metadata database to update at all. And erasure code in bitrot hashing or encryption, everything is performed inline as the data streams in, and they are committed to the drive. Even when we write to the drives, we don't trust the underlying disk file system or the controller cache. We actually write with the DMA operation. So if you pull the plug in the middle of any busy transaction, you are guaranteed that you would not lose a single transaction. Why this is important? This is, for me particularly, this is important because from an operations point of view, that you should expect things to fail all the time. Failure should be normal at scale. When you have lots of drives, lots of machines, they're going to keep dying all the time, right? And when that happens, that you don't want to lose data. And the last thing you want to do is after I acknowledge to K10 that a snapshot is now successfully written, but then I'm still erasure coding at the back end or making some changes, exactly the moving part is the one going to fail. And when it failed, I now have no way of letting you know that I told you so, that it was fine, but it's not fine now. There is no API or a mechanism to communicate it back to you. And no DevOps can understand that how to troubleshoot these kind of problems. This is where if you fail predictably. If I told Ketan that, no, I could not succeed for this reason, you know how to troubleshoot this. But I should never lie to the application saying that, hey, it's done, but it's, I'm going to take care of it, but I cannot, I couldn't do it later. That's where for me, for operational simplicity, I have to fail immediately. And the reason why others did not do it is because they couldn't get high performance. MinIO could achieve very high performance without metadata database. We could get strict consistency, so why not?
Okay. Yeah, no, backups are indeed the last line of defense for enterprises. So I hear you. So I know we are top of the hour. This has actually been a fantastic sort of 1 hour. Hopefully everybody's learned something. I think this was a good interactive session. We'll obviously make the recordings available. There are also a rich set of resources. I would definitely encourage people to go, try out both Kasten K10 and MinIO. It's a single line command, as you guys saw. And then we also have a free sort of modernizing Kubernetes backup report from 451, which is a rich read. So we'll make that available also for free. So with that, thank you very much. Thank you, AB and Vaibhav, for spending the time and talking through this. And thank you to all the participants for giving us your time and the questions. Thank you.
Yeah. Thank you, everyone. Thank you, Gaurav and Vaibhav.
Thank you, everyone. Great